Hello everyone, now we will see about pedigree analysis. Introduction. Pedigree analysis is a scientific approach to studying the inheritance of human genes. Pedigree analysis can be used to easily understand family history and the inheritance of dominant and recessive traits. With the help of a pedigree chart, one can easily identify dominant and recessive traits and also the carriers of these traits. Pedigree chart. A pedigree chart is a diagrammatic representation, chart or family tree, where one can easily determine the occurrence of a phenotype in an organism's genes passed down from their ancestors. One can study family history through pedigree charts that might have faded away over generations. Main goals of pedigree analysis. Pedigree analysis is done to determine if the mode of inheritance is recessive, dominant, partial dominant, autosomal, mitochondrial or sex-linked. Moreover, it also determines the probability of an individual or offspring being affected in a given cross. Here we have key terms like pedigree, phenotype, genotype, dominant allele, recessive allele, autosomal trait, sex-linked trait, homozygous and heterozygous. Here you can see some symbols commonly used in pedigree analysis.
Types of pedigree analysis. Based on linked chromosomes, pedigree analysis is classified into 1. Sex-linked pedigree. It is subdivided into X-linked pedigree, Y-linked pedigree. Even the X-linked pedigree is further divided into X-linked dominant pedigree, X-linked recessive pedigree, 2. Autosomal pedigree, autosomal dominant pedigree, autosomal recessive pedigree, autosomal dominant. If both parents are affected and an offspring is unaffected, the trait must be dominant. Parents are both heterozygous. All affected individuals must have at least one affected parent. If both parents are unaffected, all offspring must be unaffected, homozygous recessive. Autosomal recessive. If both parents are unaffected and an offspring is affected, the trait must be recessive. Parents are heterozygous carriers. If both parents show a trait, all offspring must also exhibit the trait, homozygous recessive, X-linked dominant. If a male shows a trait, so too must all daughters as well as his mother. An unaffected mother cannot have affected sons, or an affected father. X-linked dominant traits tends to be more common in females. This is not sufficient evidence though. X-linked recessive. If a female shows a trait, so too must all sons as well as her father. An unaffected mother can have affected sons if she is a carrier, heterozygous. X-linked recessive traits tends to be more common in males. This is not sufficient evidence though. Common mistakes and misconceptions. The presence of many affected individuals in a family does not always mean that the trait is dominant. Terms dominant and recessive refer to the way that a trait is expressed, not by how often it shows up in a family. In fact, although it is uncommon, a trait may be recessive but still show up in all generations of a pedigree. You may not always be able to determine the genotype of an individual based on a pedigree. Sometimes an individual can either be homozygous dominant or heterozygous for a trait. Otherwise, we can use the relationships between an individual and their parents, siblings, and offspring to determine genotypes. However, not all carriers are always explicitly indicated in a pedigree, and it may not be possible to determine based on the information provided. And you can able to find pedigree chart of our family that is attached in description as PDF. Have a look. Thank you.